In 1978, if you had $580 to spend on a receiver, which would be about $2,800 today, you could have purchased this Yamaha CR1020 receiver. It was rated at 70 watts per channel into 8 ohm loads at not more than 0.05% THD, and its frequency response was given as plus or minus 2.5 dB from 10 hertz to 50 kilohertz. It weighs in at about 40 pounds and has a lot of nice features which I will cover. We'll do the standard tour of the front and then the back, and then I'll take it out of its case and you can see what it looks like inside, and I will then tell you what I thought after using and listening to this nice looking receiver. Here's a close-up view of the CR1020 receiver, and starting on the left we have power on-off button, pretty obvious. We have 2 1/4-inch headphone jacks. That's a bit unusual to have 2 of them. Here is our speaker selector, and we can select between 3 speakers, or we can just turn the speakers off. That's kind of a nice feature. We have a low filter with 2 different filter turnover points, as well as a high filter with 2 different turnover points. We have our bass, mid-range, and treble controls here. We have the variable loudness control, which is a feature that I find no value in. Here is our stereo mode switch, where we can reverse the stereo. We can select left plus right, or just the left or right speakers. And we do have our record out selector here. Here's our input selector, and we just have 1 auxiliary and 2 tape monitors, and of course the tuner and phono input. We have our volume control here. The balance control is on the outer ring. We do have our tuning knob here, obviously. Here's our muting for the audio, and it will attenuate the signal by 20 dB when you go ahead and depress it. Here is our phono 1 or 2 input switch, AM/FM tuner switch. We have some different FM selections here, and this was equipped to handle Dolby FM, and you'll see that around back. We have obviously our tuning dial here. Here's our FM tuning indicator here, and then we have 2 power meters here. We do have the ability to see our signal strength for the FM right here, and when you select this to signal, I believe it's called, it will turn this into a signal strength meter for the tuner. And then we have a power LED here, an FM stereo here, and something called OTS, which is optimum tuning signal. And it's a circuit that Yamaha has for the FM that helps lock in the FM tuner when it's close. So if that is activated, it will come on. It's something that's done automatically. Here is the rear of the CR1020. Starting on the right, we have a switched AC outlet and 2 unswitched AC outlets. Our speaker connectors are here. Here is our pre-out main-in jacks, and they are joined together with this coupler switch right here. Our AM and FM tuning connectors are right here. Here's our AM tuning rod, of course. This is where the Dolby FM adapter is connected, if you had one. And we have our 2 tape monitor circuits here, as well as the auxiliary here, and our 2 phono inputs here. And each phono input has its own ground connection. Here is a view of the CR1020 with the unit out of its case. Kind of just gives an overview of what's going on there. The front of the unit is obviously here. This is just another view of the inside of the CR1020. For our AM and FM tuners, we have our U-joint assembly right here, which turns the variable capacitor here. And it kind of just shows some of the output heat sinks here, a little bit closer view of that. This just kind of shows a close-up view of, I believe the tone control boards sit in here, and maybe the phono preamp board might be back here as well. This is just another angle. You can see one of the output transistors here mounted against these big heat sinks. And we have a speaker protect relay here, and I believe the power supply rectifiers are here. And we can see we do have a fuse right there. Just another view, and you can see 2 of the output transistors for that channel, and each channel has its own driver board there. Just another close-up view of that drive shaft assembly for the tuner. You can just see a little bit closer view of the driver boards for the output transistors. And I believe these two pots here would be used to adjust the DC bias. Here is our standard THD SNR plot at 1 kilohertz with the CR1020's volume control set so we have about 25 dB of gain, and also the balance control was adjusted to get them both equal, as close as I could get, and we're putting out about 5 watts into 8 ohm loads. The THD is better than, we'll say, 0.003%. SNR is above 83 dB. I should point out that I'm using the auxiliary input for all of the measurements that aren't phono measurements or separate amplifier measurements, and the tone controls are being bypassed for these measurements. Here is the CR1020's THD SNR plot at 1 kilohertz with it putting out about 5 watts into 4 ohm loads. You can see our SNRs are better than 79 dB and the THDs are better than 0.006%, we'll call it. And overall, it looks pretty good. Here is the CR1020's frequency response from 10 Hz to 50 kilohertz with it putting out about 5 watts into 8 ohm loads. The specification is that the frequency response should be plus or minus 2.5 dB from 10 Hz to 100 kilohertz. Well, at 50 kilohertz, we're down about 1.6 dB, so we would be meeting the requirement. And at 10 Hz, we're down at worst case about 0.8 of a dB. I did adjust the volume control to favor the right channel just a little bit to get the channels to be as balanced as I could, and they are indeed pretty well balanced. And if you just look from 20 Hertz, we would be down about 0.4 of a dB, 0.3 of a dB, and at 20 kilohertz, we're only down about 3 or 0.4 of a dB. So overall, the frequency response is meeting its requirement. Here is the CR1020's frequency response from 10 Hertz to 50 kilohertz, with it putting out about 5 watts into 4 ohm loads. When it's compared with the 8 ohm load response, there's a big difference here at the low part of the band. At 10 Hertz, we're down almost, was that 2.7 dB, something like that. And in the 8 ohm case, we're only down about 0.8 of a dB. So a big difference at the low part of the band. At the high end of the band, it's kind of reversed. We're only down about 0.8 of a dB at 50 kilohertz or 0.7 of a dB. And with the 8 ohm load case, we're down about 1.6 dB. So it works better at the high end of the band with a 4 ohm load, and it works worse at the low end of the band with a 4 ohm load compared to the 8 ohm loads. Right now I have the CR1020 putting out about 71 watts into 8 ohm loads, and the volume control is still set to give 25 dB of gain. The specification for THD is not more than 0.05%, so we're a magnitude of order better than that at 0.008%, we'll call it. SNRs are right around 100 dB. Now, that is with the A weighting applied. The specification says that the THD should be 112 dB. I'm thinking that's the combined. There's actually two specs. One is 100 dB and the other is 112 dB. I think for the main amplifier by itself, it's 112 dB. So we're right around 100 dB, which is the specification going through the auxiliary or tape inputs, and I'm assuming they're involving the whole receiver at that point. So it looks like it's doing a pretty good job of meeting its specifications. And in case you were wondering, these are what the harmonics look like with the Yamaha putting out 50 watts into 8 ohm loads. What's interesting is the even harmonics right here are a bit higher than the odd harmonics. At least the third harmonic is less than the second harmonic, the even harmonic. Right now the CR1020 is putting out about 80 watts into 4 ohm loads, and I do have the A weighting applied. The power output requirement into 4 ohm loads is 80 watts at not more than 0.05%. 5%. And you can see compared to the 8 ohm load case with 70 watts, the THD went up by an order of magnitude, but it's still meeting the specification. And our SNRs are around 95 or 97 dB, we'll call it. So overall, it's doing a fairly good job of meeting its specifications. This plot shows the CR1020's output impedance from 20 Hz to 20 kHz. And if we use the 1 kHz values to calculate the damping factor, it ranges from 36 to 44, and the specification was that it should be at least 40 at 1 kHz. Here is the CR1020's crosstalk from 20 Hz to 20 kHz with the active channel putting out 5 watts into 8 ohms. There is no specification for the crosstalk. It's kind of for your information only, and this is using the auxiliary input. You can see the crosstalk varies from about 80 dB down to about, we'll call it 38 dB at 20 kilohertz. Here is the Yamaha's THD versus frequency for a couple different output power levels, and that would be into 8 ohm loads from 20 Hertz to 20 kilohertz. The 3 here, that would be the equivalent of about 80 watts into 8 ohms, and the minus 15 would be about 1.5 watts into 8 ohms. Basically, it looks really good. Our spec limit is 0.015, which would be somewhere around right here. So everything below that would be passing the requirement. And pretty much it does. It has a few points here depending on the power levels, which it looks like at the lower power levels, the THD increases a bit. But other than that, it looks pretty good over the entire frequency range. In case you were wondering, here is the CR1020's multitone response, and this is with it hooked up to 8 ohm loads, and the volume control is adjusted to give about 25 dB of gain still. We're using the auxiliary input, and the signal going in is minus 12 dBV. This would translate to a distortion-free range of about 12 to as much as 16 bits of distortion-free range. This plot shows the CR1020's THD versus output power, and this is just done at 1 kilohertz into 8 ohm loads. The specification is that it should be better than 0.05%, and indeed it is. Right here at 80 watts, we are better than 0.05%, and the specification for 8 ohm loads is 70 watts, so we're definitely better than that. And as we start increasing our THD, even here at 90 watts, we're only at 0.1%. Right now, I've terminated the auxiliary inputs into shorts, and we're just looking at the system noise level. The volume control is set for 25 dB of gain, and we're connected to 8 ohm loads. There isn't really a specification for the noise level, but you can see some of the noise is less than 400 microvolts, and our two power supply spurs here at 60 Hertz and 120 Hertz are below 86 dBV. Here is the IM distortion with a 19 and 20 kilohertz signal applied, such that we have about 5 watts for each of the channels into 8 ohms. Volume control is still set for 25 dB of gain. The specification is that it should be 0.05% at 70 watts. Well, I'm not running at 70 watts, but here at 5 watts, it is very, very low. You can kind of just tell that by looking at the 1 kilohertz tone and then the 17 and 20 kilohertz tone, and you put it all into a calculator and it looks very, very low. These are the percentages here for each of the channels, so it's way, way low. Right now I've got the Yamaha CR1020 putting out about 70 watts into 8 ohm loads, and kind of just wanted to show you what the power meters are saying. The right channel power meter is dead on. It looks pretty close to 70 watts. The left channel power meter is maybe 55 to 60 watts, so it's a little low. I'm going to see if I can't adjust that. Okay, so right now I have the CR1020 putting out 50 watts into 8 ohm loads. I've tweaked the potentiometers for the power meter circuit, and they are both reading 50 watts, which is what they should read, and that's the power output that the service manual wanted it to be calibrated at. So it is looking pretty good. I'm going to go ahead and take it down to 1 watt and just see how well it does here in a moment. And I now have the CR1020 putting out 1 watt into 8 ohm loads. The right channel is dead on and the left channel is off just a tad, but it's pretty close for government work. These plots show the effect of the CR1020's high and low filters. The blue line in the center across 0, that's with everything set flat and the filters out. And this red line is the 70 Hertz low filter switched on. You can barely see this green line, and that's the 15 Hertz low filter switched on. The high filter has 2 positions as well. It has a 8 kilohertz and a 12 kilohertz turnover point, and I'm only going from 20 Hertz to 20 kilohertz, so that's why this 15 Hertz low filter is just starting to take effect over here. Right now we're looking at the frequency response of the preamp section only from 20 Hertz to 20 kilohertz with a 0 dBV signal applied. All the tone controls are set flat, the filters are out, and the volume is set for 0 dB of gain. And what I'm going to do is play with the loudness control, and I'm going to move it over to 5, and let's see what happens. Okay, with it set to 5, we get our smiley face kind of that you often see with a loudness control on most other receivers or integrated amps or preamps. However, we're down, at least at 20 Hertz, we're down, what is that, 4 dB? So normally you will see a shift of 4 dB here, and then at the high end of the band you'll see another shift of a couple dB. But what Yamaha does, and I've seen this on other integrated amps, is they actually attenuate the signal and then apply this loudness fix, which I'm not sure what the reasoning, but it's something that I don't understand and I don't like. So I would never be using this loudness control. I don't really know its purpose, the way it does things, but we're going to go ahead and move it to 10, which is the maximum loudness, and we'll see what happens. So at 10 you can see it's even attenuated things more, especially here in the mid-range. If you left the volume control the same and you went ahead and adjusted the loudness control to maximum, you have more of a pronounced effect, but it is still attenuating your signal. So right now the loudness control is off, and I've adjusted the volume control down. It was at maybe about a 5 or a 6, and now it's at about 2.5, something like that. So the gain has dropped a lot. So we were at 0 and we're down about 13 dB. And I'm going to go ahead and move the loudness control over to 5 and see if the amount of volume has an effect. So it's still attenuated, maybe not as much at the lower levels, but it's not boosting anything. So when I apply a loudness control, I want my bass to go up and I want my trebles to go up, but that's really not what happens with the Yamaha's loudness control. Right now we're looking at the CR1020's phono response. In this case I'm using the Phono 1 input and I'm measuring at the tape monitor 1 output, and I've got a 5 millivolt signal going in. You can see our THD is really down there. It's better than 0.002%. SNR is not bad, 64 dB to 66 dB. There's obviously some noise here on the right channel. But other than that, it looks pretty good. Now I do have the RIAA weighting applied, so if I didn't, it would kind of slope like this. But here's what it looks like with the weighting, and our gain for the phono stage is about 36 dB, we'll call it. Now it does have 2 phono inputs, and they are both for moving magnets. Here's the frequency response of the Phono 1 input to the tape monitor 1 record output with a 5 millivolt signal applied. And it looks really good. At 20 Hertz we're down maybe half a dB, and then we go up about 0.2 of a dB depending on the channel, and then it's pretty flat. So overall I would say this has a very nice phono stage frequency response. Right now we're looking at the frequency response from 10 Hertz to 50 kilohertz
of the amplifier section only of the CR1020, and it's putting out about 5 watts into 8 ohm loads. You can see the channels are fairly well balanced. At the low part of the band, maybe they're as much as a tenth of a dB, maybe 2/10 of a dB at 10 hertz, and then they're pretty much on top of each other. At 50 kilohertz, we're only down about 4/10 of a dB, and at 10 hertz, we're down maybe 7/10 of a dB or maybe 6/10 of a dB, depending on the channel. Right now, we're looking at the amplifier section only of the CR1020, and it's putting out about, we'll call it 71 watts into 8 ohm loads. The gain of the amplifier is about 30 dB. THD is better than 0.006%, we'll call it, and our SNRs are at least, we'll say, 90 dB. So it looks pretty good. It's meeting the THD specification. And in case you're wondering what the harmonics look like, I'm just showing the left channel because it kind of shows the numeric values of the harmonics. But you can see that the even harmonic, the second one here, is greater than the third harmonic by just a little bit, and so on. So that kind of just gives you an idea of what's going on with the amplifier section. Here is the frequency response from 10 hertz to 50 kilohertz with a 2 volt RMS signal being applied to the auxiliary input, and we're measuring at the preamplifier output. So we're just looking at the preamplifier stage. The volume control has been adjusted for 0 dB of gain, and I did tweak the balance controls to try to get them pretty close, and they're within, I would say 2/10 of a dB worst case. Overall, you can see at 10 hertz we're down maybe 6/10 of a dB, and at the 50 kilohertz we're down maybe 8 or 9/10 of a dB. So overall, the frequency response looks great, especially when you look from 20 hertz to 20 kilohertz. We're within 2/10 of a dB. I've separated the preamp from the power amp sections now using the switch in the back of the CR1020, and we're just looking at the THD SNR plot at 1 kilohertz with a signal that is 2 volt RMS going into the auxiliary input, and we're measuring at the preamplifier output. And it looks really good. You can see we've got a 100 dB SNR. THD is better than 0.005%. THD plus noise is minus 87 dB worst case. And I did adjust the volume control so we had 0 dB of gain. Right now we're looking at the difference in phase between a signal going into the CR1020's auxiliary input and coming out of the left channel's amplifier output, and that would be with it connected to an 8 ohm load. At 1 kilohertz, there is very little difference in phase. If we come over here to 10 kilohertz, we can see there is a phase difference between the input and output. I'm guessing it's under 10 degrees. At 100 hertz, the phase difference is less. It's maybe 5 degrees or so. This is the difference in phase between the left and right channels, and they're both connected to 8 ohm loads, and at 1 kilohertz, there is no difference in phase. The same goes for the difference in phase at 10 kilohertz. It looks like both channels are about the same. Looking at the rise time between a signal going into the auxiliary input and coming out of the left channel output, the rise time is calculated at about 3.22 microseconds. Now, there is no specification for any of the phase deltas or the rise time. It's just kind of there for information in comparison to other pieces of gear.
This particular Yamaha CR1020 came to me via my good buddy Ian from his personal collection, and he said it was last used several years ago. So the first thing I did is connect it to my loads and hooked up the Quansilum QA403 analyzer, turned it on, and I'm not getting any signal out of it. So did a little troubleshooting, separated the power amp and preamp. Power amp section looks okay. The preamp section is where the damage is. And it turns out it was the muting switch was intermittent. And I ended up cleaning and lubing all of the switches and the potentiometers and then everything was good. As you saw from the test data, it pretty much met all of its requirements, that at least the ones I measured. I believe the only one that was off a little bit was one of the damping factors was off a bit, but other than that, everything looked pretty good. One of the power meters needed a little tweaking, and you saw that, but it pretty much did a really good job. Now, it's not fully original. It looks like there was some heatsink grease that was a little bit too wide, the way they spread it. So I checked the output transistors, and they're not the original ones that the schematic says should be in there, at least on the one channel. So I think at some point it had the output transistors replaced, but it appears to me to be original. Other than that, and maybe they replaced some driver transistors. I couldn't really tell if they had or hadn't, but for the most part, it seems to be, you know, pretty much original or close to it. I do like the look of these particular Yamahas in these series. This was in the middle of the price range, I think, for those years. And for as old as this thing is, to have held up the way that it did electronically and cosmetically, I think is just a testament to the way Yamaha built stuff then. Of course, my nitpick with Yamaha, at least the ones with their loudness control, call it something else, because I don't know why it's a loudness control. It attenuates the signal, as you saw in the test data, and you know it does give you the smiley face, but it's many dB lower, whereas most loudness controls boost the bass and the treble or both, and they still give you a smiley face. But I don't know their thinking. I'm sure some of you will tell me what their thinking is in the comments, but to me it makes no sense. Call it some other kind of a control, a loudness attenuator control or something. But that's my only nit with it. It does have a lot of features, and I actually owned one of these. It was given to me. It was need a little bit of work, and I ended up selling it on Craigslist years ago before I was doing the channel, well before that, and I kind of wished I kept it. I really do like the looks of these guys, and it performs well. I didn't play with the AM tuner, but I did check out the FM tuner, and it did what it was supposed to. The dial accuracy was right on, and the LEDs that are supposed to come on came on at the right point, and the tuning indicators seemed to work just fine. So the FM tuner was in great shape after all these years. As far as listening to it, I connected it to the Wilson Watt 3 Puppy 2 loudspeakers, and I used my little Surfance music player, and I listened to a variety of music. It sounded really good. I thought it sounded excellent as far as that. The only issue that I had, and I had to hook up a whole other system to see if there was something, something else going on. But when you boosted the bass a little bit, sometimes you would get some distortion. And if you go back to the THD versus frequency and power level plot, you can see right around 20 hertz, there's a big boost in distortion. And I think I capped it at some point, but it could have been a couple percent. I just didn't show the top of the graph there. And it's possible when I had the bass boosted up, because there was no loudness control to use, I boosted up the bass a notch or two, and it may have been putting some distortion in that somehow got to the speakers. My speakers won't do 20 hertz. The Wilson Watt 3 Puppy 2s really won't go down that low, so it could have been just something feeding in and causing something else to happen. But it was only on certain tracks, and it was when I played it real loud. I got this baby going to over 92 dB SPLs, and no complaints out of it. It never got more than slightly warm at the top, and the power meters were hitting maybe 40 watts into 8 ohms according to what they were showing. That was just peaks, but average is probably about 25 and that watts into 8 ohms, and that was plenty of power to drive those Wilson Watt 3 Puppy loudspeakers in. And for the most part, I just thought it just sounded nice. It's very clean sounding amp. There were no pops or clicks when I turned it on or off, and when I just terminated the auxiliary inputs with shorts and listened for hum or hiss, it was just very, very small amount of hiss. So it's pretty quiet, and I thought the phono stage, it tested good. It's not something I normally listen to, but I think this particular one would work rather well as a phono preamplifier if this were yours and you were going to hook it up. So I think they're a great receiver. I looked quickly on eBay, and they're going for $650 to $1,500 depending on what's been done to them. But they're a nice piece of gear if you can pick one up for a reasonable price. They would work well for most people. I mean, I don't recommend using them as a separate amp or preamp, but they certainly test really good as either an amp or preamp. So, it's a nice piece of gear, and I appreciate Ian letting me test it. It may be part of an A/B shootout that we would do against another receiver, for a future get-together for my audiophile group, I guess you would call us, and we're looking at doing 2 vintage receivers, blind test, A/B testing, and this might be one of them. So anyway, I thought I would just mention that. Once again, I thank you for watching this video. If you enjoyed it, please give me a thumbs up. If you have questions or comments, you can leave them in the appropriate area. And if you have not subscribed to the channel, I hope you will do so. So until next time, have a great day or night.